morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about input-output instruction. So, in the input-output instructions, first of all, we have to go to what are the useful instructions are there for the input-output and how we are giving the instructions to the computer. So, a computer can serve no useful purposes unless it communicates with an external environment. Instructions and the data stored in memory must come from some input device. Computational results must be transmitted to the user through some output devices. Commercial computers include many types of input-output devices to demonstrate the most basic requirements for input and output communication. We will use as an illustrate a terminal unit with a keyboard and a printer. Suppose we have one computer is there. If you don't have any inputs or outputs of this computer, what is the use? There is no use. That is a useless. So that is the reason we have to take any of the computer. We need some inputs and outputs for that one. So definitely we have to connect input and output. Input means we will connect keyboard, mouse like this, and output I am taking as a printer or speaker or anything else. Okay, buzzer. So without a keyboard and mouse, how can we use? Okay, so definitely computer we need inputs and outputs. So we have to use inputs and outputs to the computer. How can we monitor? Means through the instructions. Through the instructions we have to monitor. So instructions are nothing but we are giving the data storage of the memory to the input devices, and computational results must be transmitted to the user through some output devices. Suppose we have to take not a computer of personal, I am taking as a commercial computers. Include many types of input and output devices to demonstrate the most basic requirements for input-output communication. We will use as an illustrate in the terminal of keyboard and printer. So these are taking as a, what is a keyboard here? I am taking input. Printer is a output. So input output, how can we connect? Means we have to connect computer. So for the commercial or personal computer, anything, we need some keyboard or mouse to the input, and the printer also we have to connect it. So input and outputs are connecting to the computer through the instructions to data storing in a memory. And input output configuration. First I am taking here keyboard. Is it input? Yes, it is the input. Block diagram of input output configuration for basic computer. So keyboard will give the information to the computer. That is called the transmitter interfacing. Interfacing means inputs and outputs are externally connected. That is called interface. So any of the input and output devices are interfacing to the computer. So it is a transmitter interface. Why I am transmitter means I am talking about input to the computer, input to the device or computer. That is a transmitter interface. Okay, it is a INPR, interrupt register, or so it is going to the accumulator, AC accumulator. So this transmitter interface is going to the interrupt register. If interrupt register is INT0 or INT1, INT1 means it is enabled. So I am giving some interrupt 0 or interrupt 1, enable or disable. So it is going to the accumulator. Accumulator is nothing but a data store through the registers. Data store through the registers. So it is going to the output register, OUT or output register. Then it is going to the receiver interface. Receiver interface is nothing but a output to the device. Okay, it is going to the printer. So printer is output. Yes, it is the output. So input to output. What are the steps are there? First one, keyboard. Keyboard is data passing to the computer. Data passing to the computer. That is the transmitter interface. Then it is going to the interrupt register. If interrupt register equal to INT is equal to 0, it is data will not transfer. INT equal to 1 means data will be transferring through the accumulator. Accumulator is a data storage in the form of registers. Okay, accumulator is passing the data through the registers to the output register OUT, or that is a output register through the receiver interfacing, and then go to the printer. So suppose I have to print is nothing but a output data. So I'm giving the data through the input. Same data is came to the output. Okay, data input and data output. But meanwhile, what we need at the output stage, I'm taking as a computer registers and flip flops. Flip flops are using but 1 bit of storage. 1 bit of storage. Computer registers are there, maybe 8 bit of storage. More than 1 bit. More than 1 bit I am taking as a register. Only 1 bit means I have to take flip flop. And the next, serial communication interfacing. Receiver interface is accepting the input data through INPR to OUTR. Okay, in the OUTR the data is there. Yes, the output data is available in the OUTR. So receiver interfacing is passing the data from OUTR to printer. Okay, so we need one interfacing. Which type of interfacing means I need serial communication interfacing, not a parallel. Serial means 1 by 1. 1 bit to first 1 bit is transferring 1 0 1 0 1 0 1 1 like this. So bit by bit will be transferring like this. It is a serial communication interfacing. So keyboard transmit interfacing, interrupt register, accumulator, output register, receiver interfacing, and printer. So data input, data output. It is a data output. It is a input output configuration of a basic computer. The input output terminals send and receive information. The amount of information transferred will always have 8 bits of an alphanumeric code. The information generated through the keyboard is shifted into an input register INPR. The information for the printer stored at the output register OUTR. Registers INPR and OUTR communicate with a communication interfacing serially and with AC in parallel. The transmitter interfacing receives information from the keyboard and transfer into the INPR. The receiver interface receives the information from OUTR and sends into the printer serially. So here it is a discussion about the input output instruction. Suppose I am taking input to output. So what is the process going on between the input to the output? The amount of information transferred. So input will do what will do? Data will pass through the interface. Through the interfacing. So through the interfacing means I am taking here 8 bit of register. 8 bit of register to pass the information, to pass the data from the input to output. Okay, so it is I am taking as a this 8 bit register I am taking as a INPR input register INPR. So this INPR input register is accepted the input of 8 bit data through the interfacing, and the information for the printer is stored at the OUTR output register. So input register is a keyboard information and OUTR is the printer information, printer data. It is a keyboard data and it is a printer data. So keyboard data through the INPR and the printer data at the output side through the OUTR, and the register INPR and OUTR communicate with a communication interfacing serially with accumulator in parallel. So INPR and OUPR are the input registers and output registers through the communication with a serial communication interfacing. And here I am using accumulator to passing the information from input to output. The transmitter interface receives the information from the keyboard, that is a INPR input register through keyboard. So the receiver interface receives the information from output register, sets the information serially. So input keyboard to INPR, input register, and output OUT output register to printer. Here, one bit of information, that is a flag FGA, is control of flip-flop. It is a one bit of information or data. When I'm using one bit of information, that is a FGI. One bit of input data is a FGI, is a control flip-flop. Flip-flop is using for one bit information or data. So the flag bit is set to 1 when new information is available in the input output devices, and clear to 0 when the information is accepted by the computer. Flag bit equal to that means new information. Set to 0 is equal to, it is when the information accepted by the computer. Already accepted. Already accepted. So set to 0 means already accepted, means already the data is passed. Set to 1 means already printer given the output. Okay, now it is free. It is now it will take the new information, that is set to 1. Here the flag is needed to synchronize the timing rate difference between the input device and the computer. So the process of information transfer is as follows. Initially, the input flag FGA is cleared 0 when a key is struck in the keyboard and 8-bit alphanumeric code is shifted into INPR, and the input flag FGA is set to 1. As long as the flag is set, the information in INPR cannot be changed by striking another key. The computer checks the flag bit. If it is 1, the information from INPR is transferred in parallel to accumulator and FGA is cleared to 0. Once the flag is cleared, the new information can be shifted into input register by striking another key. So here normal data is passing through from input to output, but here I am taking initially the FGA is cleared to 0. Already we discussed here. The FGA is cleared to 0 means already the information is accepted by the output. But here, when a key is struck in the keyboard, so any of the information is struck at the input side, the 8-bit alphanumeric code is shifted. We have to shift the alphanumeric code into the input register, and the input flag FGI is set to 1. As long as the flag is set, the information in INPR input register cannot be changed by striking another key. Already the information is struck at the input side, so flag FGI is set to 1, means new information is ready. But here already one data is struck, then new information is not come. It is striking by another key, and the computer checks the flag bit is 1. The new information is from INPR is transferred through the parallel. Already we discussed serially, but here what will happen? Already struck some information. So what will happen now? We have to go not serially, we have to go parallelly to transfer the data. So the flag is cleared, new information can be shifted into the through the INPR register by striking another key. So when we have to go serially, that means INPR register will serially transfer the data from input to output. So that is called set to 1. That means new information will pass. New information will pass. The output register OUTR works similarly, but the direction of the information flow is reversed. Initially, the output flag FGY is set to 1. When it is set 1 means new information will pass from input to output. The computer checks the flag bit 1, then the information from accumulator is transferred to the output register through parallelly, and it is cleared to 0. The output device accepts coded information and prints the corresponding character, and when the operation is completed, it FGO equal to 1. When operation is completed means FGO equal to 1. When FGO equal to 0 means it is passing the data. And the computer does not load a new character into output register when FGO equal to 0. When FGO equal to 0 means output register will not transfer the new information. Load a new character into output register when FGO equal to 0. FGO equal to 0 means output register is passing information. FGO equal to 1 means it is free. Then go for the new information. And input output instructions. Input and output instructions are needed for transferring information to and from accumulator register, checking the flag bit, and controlling the interrupt facility. So here I am taking 0 to 11. That means it is a 12 bit of information. That is the input output operation. And 12 to 14 is a 1 1 1. That means here opcode. It is a opcode. Opcode means add, mul, division, compare, CMP, compare, like this. So these instructions I am taking as a opcode. It is a 3 bit. So it is flag equal to 1 or flag equal to 0 depends on your input and output operation. So transferred information from accumulator register, that is a what you are taking input and output, that is this one. And what is the opcode you are using, and what is a flag register means if it is I equal to 0 or I equal to 1. So checking the flag bit and controlling the interrupt facility. Input output instructions have an operation code 1111 and are recognized by the D1 to D0 to D7, that is a 8-bit information, and remaining bits of the instructions specify the particular operation. These instructions are executed with a clock transition associated with timing signal T3. Each control function needs a Boolean relation D7 to T3, which we designate for convenience of symbol P. So any of the opcode it will be depends on your flag bit. Flag equal to 1 or 0. So input output reference instructions. The instructions are for communication between computer and outside environment. The instruction register, it is taking as 12 to 14 means 3 bit is 111. It differentiates it from memory reference, and IR15 is a 1, differentiates it from register reference instructions, and the rest of 12 bits specify the input output operation. Is a 12 bit of input output operation. It is a 3 bit IR instruction register, 3 bit. Total it is a IR instruction register. Total it is a instruction register, and IR register 12 to 14 is a 311, differentiates from memory reference, and IR equal to 1 means differentiates from register reference instructions. Register reference instruction. So total 16 bit of data is dividing with 1 to 12 bit is for input output operation, 3 bit is for opcode, and 1 bit is for reference. So total 16 bit. So input output instruction flowchart. I am taking SC tends to 0, program counter tends to program counter is to address register AR. Here two conditions are there. PC plus 1 to PC means next instruction. What is the next instruction? Address, that is PC plus 1 is going to the present address. Next is going to present means present address is going on. Next present is completed, going to the next. And this PC tends to address register. Now PC plus 1 to PC means next instruction is completed. Now present is completed, next is started now. That is a PC plus 1 to PC. So now what will happen? Mem of AR means address register of the memory. What is the first memory is there? What is the address of that one? That is a M of AR. It is going to the instruction register AR. So IAR instruction register tends to M of AR when PC to PC plus 1. Suppose I don't have any PC plus 1. Suppose the loading function is PC. So what will happen? Address register AR. PC means it is registering address AR, but I am taking PC plus 1. PC plus 1 means this M of AR going to the instruction register IR, and it is decoding operation. Decoding means we are converting into the binary. So that means instruction register, how much size? IR of 15 means 16 bit of instruction register is to be I, that is 0 to 11 is the address, and 12, 13, 14 is an opcode, and 51 is the reference instruction. And if it is D7 equal to 0, the data is 0, it is a memory reference. What is a memory reference? It is a lost one. It is a memory reference. If it is memory reference is 0, that means lost one is 0. What will happen? It is going to the direct or indirect. Okay, that is the 0 or 1. It is again direct or indirect. If this register equal to 1, so what will happen? Input output equal to 1 and it is 0. Here indirect direct mode when memory reference equal to 0. But here memory is equal to 1, 1. Input output equal to 0, 1 or input output equal to 0. If input output equal to 1, then it will be execute input output instruction SE to 0 and execute register reference SE tends to 0 and M of AR to AR. Here it is a nothing. So if it is nothing means it is directly executing the memory reference instruction, that is SE to 0. Okay. So input output instruction from starter to end, what will happen means it is two conditions are there. That means reference is 0 or 1. 0 means memory reference, 1 means register reference. So memory reference means if 0 direct, 1 means indirect. Register reference means register equal to 0 or input output equal to 1, 2 type. Here the control function is distinguished by 1 bit of 0 IR equal to 11 by assigning the symbol B of IR. The control functions can be denoted by for I equal to 6 through 11. So it is a table of input output instructions when accumulator, input register, FGA, input character, input flag, output flag, interrupt enable and interrupt disable. These are the references. So now discuss it today. Input output instructions, how can we communicate to the computer? So through the instructions we have to monitor input and output. So keyboard, mouse are the inputs and the printer and the speakers or etc. are the outputs of this one. And how we are connecting keyboard means input to output, input data to output data, how the process is going on. Keyboard to transmitter interfacing means we are interfacing the transmitter keyboard to computer. INPR means input register. The input data is passing through the input register to the accumulator, and this accumulator will pass the information to the output register, and this output register will pass the information to the receiver interface at the receive output stage, and it is passing through the printer output. So input data is converting to the output data through keyboard to printer, and it is the input register. OUTR is the output register, and it is flag 0 or flag 1. FGA equal to 1, what will happen? FGA equal to 0, what will happen? And it is 0, FGA equal to 0 means clear, FGA 1 means output data is passing or loading. Here input output instructions I am taking as a 0 to 15, that is 0 to 11 is the input output operation, 12, 13, 14 is the opcode, and 15 is a register reference value. It is the input output reference instructions, that is from 0 to 11, 12 to 14 and 15th one. Here it is a flow chart of input output instructions from source count to SC to execute memory reference of instructions. So SC tends to 0 to last one, SC to 0. But how many conditions are there? Input output condition and memory reference, register reference and memory files. So two conditions we have there. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.